Welcome to the DIY Honda Garage channel. The DTC P0105, indicating map sensor out of range, refers specifically to issues involving the manifold absolute pressure map sensor in your Honda HR-V model year 2016 to 2022. This sensor plays a crucial role in monitoring the pressure within the intake manifold, translating it into electrical signals for the engine control unit, ECU. A malfunction in the map sensor can lead to improper engine tuning, resulting in performance issues and reduced fuel efficiency. It is vital to perform thorough diagnostics based on the provided troubleshooting steps to identify the exact cause of the DTC. Each solution point is based on data obtained via the Honda Diagnostic System, HDS, ensuring a comprehensive approach to problem solving in a systematic manner. The map sensor, responsible for assessing manifold pressure, plays an essential part in controlling engine operations and optimizing fuel delivery. In the Honda HR-V, this sensor is typically located on or near the intake manifold, ensuring it accurately picks up manifold pressure readings. It connects to the vehicle's engine control unit, ECU, through a wiring harness. Electrical signals generated by the map sensor help the ECU determine the correct air-to-fuel ratio needed for optimal engine performance. A reading outside the normal range can trigger DTC P0105, hence why proper connection and voltage checks are critical during diagnostics. The accuracy of these connections directly affects the vehicle's performance and emissions. The causes of DTC P0105 generally include a faulty map sensor, which may be malfunctioning due to wear and environmental factors. Open or shorted wiring in the harness connecting the map sensor to the ECU can also lead to erroneous readings, with exposed or damaged wires causing intermittent failures. Additionally, poor electrical connections, either at the map sensor or the powertrain control module, PCM, may disrupt signal transfer. Each of these potential issues requires thorough checks using the HDS to verify functionality and continuity. By addressing these causes systematically, repairs can be targeted effectively, restoring proper function to the map sensor circuit. Drivers may experience several symptoms when encountering DTC P0105. Common indicators include poor engine performance, where the vehicle may struggle to accelerate or maintain speed due to improper air-fuel mixtures. Increased fuel consumption often accompanies this, as the ECU attempts to compensate for the erroneous readings from the map sensor. Additionally, an illuminated check engine light serves as a warning, indicating that the vehicle's onboard diagnostic system has detected an issue. Drivers should not ignore these symptoms, as they can lead to more significant engine damage if not addressed. Timely diagnostics can help pinpoint the exact cause and mitigate potential performance issues. In the first troubleshooting step for DTC P0105, start by turning the vehicle to the on position without starting the engine. Utilize the Honda Diagnostic System, HDS, to check the map sensor values. Specifically, you will need to monitor the voltage, looking for a reading of less than 0.32 volts. If the reading confirms this threshold, this indicates that the failure has been duplicated, and you should then proceed to the next step to narrow down the issue. If the voltage does not match the specified threshold, you will need to follow additional problem verification steps to assess possible intermittent failures or connection issues. For the second troubleshooting step, you will once again check the map sensor using the HDS. This time, you should look for values greater than 3.25 volts. If the reading confirms this threshold, it indicates that the failure has been duplicated. In this case, you need to proceed to further steps outlined in the diagnostic protocol. If the voltage does not confirm the specified threshold, it points to a potential intermittent failure issue. You should then inspect all electrical connections associated with the MAP sensor and the powertrain control module, PCM, for any signs of poor connections or loose terminals, as these issues can lead to erroneous data being sent to the ECU. In this step, you will turn the vehicle off and disconnect the MAP sensor 3P connector. After doing so, put the vehicle back into on mode while the MAP sensor remains disconnected. With the HDS, check the voltage again. You are looking for values less than 0.32 volts. If the reading confirms this, it indicates that the testing is following the right course, and you should move on to further troubleshoot to confirm the exact component failure. If the threshold is not met, you will need to look at other potential failures in the MAP sensor system or the associated wiring. For step 4, you will measure the voltage between specified test points while keeping the MAP sensor 3P connector disconnected. Check the voltage between test points 1 and 2 as per the diagnostic instructions. If you find a voltage of approximately 5.0 volts, it's essential to replace the MAP sensor as a likely source of the issues detected. However, if you find that the voltage is not at the expected level, this indicates that the fault may lie elsewhere, and you should continue with the diagnostics to trace additional components along the circuit. In this step, you will turn the vehicle off and jump the short circuit switch SCS line with the HDS. Then wait for more than 1 minute to allow the system to reset. After this, disconnect the PCM connector B51P and check for continuity between the specified test points. The continuity check will assess if the VCC1 wire is intact. If continuity exists, this indicates that the wire is functioning correctly, and you should consult authorized service information regarding DTCs or consider substituting in a known good PCM to confirm proper functionality. If there is no continuity, repair the open circuit found in the VCC1 wire. For troubleshooting step 6, the vehicle should again be turned off. Similar to the previous step, the SCS line is to be jumped with the HDS with a wait time exceeding 1 minute. Next, disconnect the PCM connector C51P and check the continuity between specified test points. This test will determine if there's a short in the MAP PB line. If continuity exists, the wire is considered operational, and repairs should focus elsewhere, possibly on the MAP sensor itself or the PCM. If continuity is not present, remedy the short found in the MAP PB wire to restore functional connectivity. In step 7 of the troubleshooting process, switch the vehicle to the off position and then disconnect the MAP sensor 3P connector. Using jumper wires, connect the terminals A and B on the connector. Once the jumper wire is secured, turn the vehicle to on mode and check the HDS reading for the MAP sensor. If the reading exceeds 3.25 volts, this indicates successful operation, and you can proceed to the next diagnostic step. However, if the voltage does not meet the threshold, the MAP sensor should be replaced, as it is likely defective and affecting the overall vehicle performance. For troubleshooting step 8, power off the vehicle and remove the jumper wire from the MAP sensor connector. Then, turn the vehicle back to on mode and measure the voltage between the specified test points again. The target reading needs to be around 5.0 volts. If this voltage is present, it signifies that the connection channel is functioning correctly. You can continue with additional steps to troubleshoot possible further issues, or you may conclude that the components involved are operating as designed. Should the output not meet the required thresholds, further testing is warranted to identify open circuits or faults needing repair. In this 9th step, you will again turn the vehicle to the off lock mode. After jumping the SCS line with the HDS, wait for over 1 minute. Heat the system and then disconnect the PCM connector C51P for your next continuity check. Assess continuity between the designated test points for the SG1 line. If continuity is present, it means the SG1 wire is intact and functioning properly, allowing you to explore further issues as they relate to the DTC. If continuity is absent, it's time for repairs on the open circuits within the SG1 wire to restore proper functionality. For the final step of troubleshooting, turn the vehicle to the off position. Jump the SCS line with the HDS once more and wait for the system to reset. After waiting, disconnect the PCM connector C51P and check for continuity between the map sensor and the PCM junction regarding the map PB line. If continuity is present, the map PB wire is in good condition. In contrast, should you find no continuity, you will need to inspect and repair any open circuits in the map PB line to restore normal sensor operation. Completing this final continuity check finishes the troubleshooting process for DTC P0105. After completing the necessary repairs associated with DTC P0105, it is crucial to verify that the issues have been resolved. Start by checking the diagnostic trouble codes, DTCs, again to ensure that P0105 is not present. Next, confirm the proper functioning of the map sensor using the HDS or through a test drive. Engaging in a test drive allows you to assess how well the vehicle operates under various situations. By monitoring for any persistence of symptoms or recurrence of the DTC, you can ensure that the prior issues have been successfully addressed. Completing this verification phase is vital to ensure long-term reliability of the map sensor and overall engine performance. To help prevent future occurrences of DTC T0105 and similar issues, engaging in regular preventive maintenance is highly recommended. Schedule periodic inspections of the map sensor to ensure it is functioning well and free from debris or damage. Additionally, routinely check all electrical connections related to the map sensor and other components to confirm that they remain tight and corrosion-free. Regular engine servicing, including oil changes and filter replacements, contributes to the overall health of the vehicle's engine management system. By maintaining these components and following manufacturer-recommended service intervals, you can enhance the reliability and performance of your Honda HR-V, mitigating the risk of related troubles. In conclusion, understanding the significance of diagnostic trouble code P0105 and adhering to the predefined troubleshooting steps is crucial for maintaining the performance of your Honda HR-V. By diligently following the steps outlined, potential issues can be identified and addressed promptly, minimizing the risk of engine performance degradation. The role of the map sensor is pivotal to the engine control process, making its proper functioning essential for optimizing vehicle performance and fuel efficiency. Furthermore, proactive preventive maintenance helps in mitigating similar issues in the future, ensuring lasting vehicle reliability. Remember, addressing DTCs efficiently not only enhances your driving experience, but also extends the lifespan of your vehicle. Please like and subscribe to the channel. See you next time.